bit of a provocative slide to get started. But first, let me introduce myself. I've been with Procter & Gamble 24 years. I'm responsible for a group that's called Smart Platforms, which is in our corporate functions engineering. I'm also responsible for our industrial controls and automation discipline in the company. So what I'm going to talk about is a major initiative inside of Procter & Gamble of how we're bringing AI and machine learning to the equipment, right down to every equipment area, every piece of OEM equipment, so we can unlock the potential of this for all across manufacturing. This slide I use with my team to be a bit provocative, and I use this slide in two different ways. If I'm talking with my IT friends, I actually change the title of this to not be intelligence movement, but independence movement. What I mean by that is this idea of IT-OT is very powerful in the convergence. However, sometimes it can be limiting in manufacturing because it brings a lot of complexity to the larger cloud, the larger on-premise systems, when sometimes we need to just operate at the pure OT level near the equipment, level 0, level 1. If I'm talking to the broader community, it's about actually unlocking this potential of intelligence. And so what I'm going to talk about is our committed approach to freeing up the data from the systems, having the proper communication, having the proper machine learning development, and be able to do this at the most practical level in manufacturing. Because as you all know, it isn't about the gadget as we talked about today. It's about moving the culture, moving the confidence. So what we've created is a bit of a marketing campaign and some products and services. So we have something called the Smart Box, which I can talk to you about separately on the side if you'd like, but it's a edge appliance that sits right with and around the PLC. So sits in the panel, sits as an industrial PC, either a GPU or CPU, and we work with certain partners to enable that. That particular appliance then frees up the data, contextualizes the data, serves it into a service that we call WISE. So WISE is a broad approach to what I call the method of manufacturing machine learning. And if anyone knows anything about P&G, we have system after system after system, but we didn't have a system or a work process to enable machine learning at the manufacturing level. And these two are working together to deliver this multiple $1 billion of opportunity to freeing up what is needed and can be obtained by putting AI and machine learning at the most granular level at the machines, and then having it coordinate all the way up through the higher cloud and other on-premise. So I have another analogy. What I didn't tell you is I came from the US Air Force 24 years ago. So there's a lot of discussion about Air Force, Army, Marines, Navy. So I feel like my role has flipped. My premise is that the cloud and all of the very powerful things above us is the Air Force, but on-premise, right near the machine, is the Army. And so guess what happens when you want to win a war? You can have air superiority and have all that technology, but you got to win the ground war. So our story is a bit about how we're attacking the OT and winning the ground war with technology, yet still having to be complemented by the Air Force, which is the cloud and other exciting technologies. So as we got into this over the last 3 years, we found 4 predominant challenges that we had to solve as we attacked the OT. First of all, P&G has a whole range of equipment, from OEM equipment that we spec'd, decided the software, decided the vendors, even wrote some of that software. And then we have machines in certain businesses, I won't tell you which businesses, that we might not even know where the software is. We just hope that it's running, the buy and bolt down sort of mentality. So for my job is to make sure all of the P&G businesses and all of the equipment, we can get to the right data and have it be contextualized and in many cases time-stamped. Then once we have the data, we have to know how to use that data to build a model, a machine learning model, which is a very different practice for the traditional controls community. So we got to merge controls engineers with data scientists and subject matter expertise to build a machine learning model. Then once we've had that model and it's been tested and validated, we have to operationalize that. And what we mean by that is it's not operationalized in the cloud, sending off just some decision support to some role that doesn't even know they need it. No, operationalized at the equipment level in a deterministic algorithm in the stream, in the pipeline. And then finally, once we've done that, hey, it's got to last, right? We all know the manufacturing mentality of operations. It's got to run 24/7. The lowest losses, fully available, and if it does fail, who's helping me that hour to get it back running? So we're working to solve this and have solved much of this with this Smart Box and WISE concept. So as we got into it, and we had to train our leaders that, it's not about the hardware and software only. It's about hardware and software interfaces, connections, and as well the machine learning methodology that helps you build the machine learning model and then follows those other challenges all the way to success. So I'm a bit of a brand guy, so I created these names that are synonymous, and even at the highest levels of the company, even our CEO knows what a smart box or what WISE is as a part of machine learning AI, and that's an accomplishment unto itself. So what we realize is if we're going to win with our manufacturing leaders, it has to be practical, it has to be fast, it has to be easy, it has to build confidence and culture. This is not about the possibility of machine learning, it's how can they participate? How can they participate at an affordable cost? How can they participate in it fast? How can they learn and build confidence? So we have some taglines in this is you get data in 30 days, you get a machine learning model in 90. And at that point, do you have something or you don't have something, right? So this is a big difference in what I had experienced in my first 3 years in smart platforms. Then we do need to coexist with our on-premise servers, with the cloud, and what is this large methodology of machine learning. So we got some brand names on the bottom and where they fit. So there's the control edge, there's the on-premise, what I would say OT edge. Then you have your cloud solutions, back to the OT edge, back to the control edge, and that whole cycle continues and continues on and on and on as we develop this methodology of machine learning. So the punchline for today, I just wanted to show you that we have a committed program, that we have a movement that we're creating to put thousands of these control edge devices working on premise, putting thousands of algorithms in production to unlock billions of dollars of benefit. But the punchline in here is you've got to have the proper architecture, you got to have the proper interfaces, the proper connections, and we've got to free up many of these key devices that have been somehow locked in these proprietary infrastructures. And P&G has been very good at setting standards, whether it's with one vendor or another and then staying with it over multiple decades. Well, the reality is if we keep operating that way, we will limit our ability to free the OT and limit our ability to enter into some of these new things that we're going to talk about with FLC. But I highlighted in green some of the things that are really resonating in our approach and use of OPC. So the compute to compute, multiple smart boxes working together or working in computing partnership with the cloud. We have the compute to the device, right? So we're doing a lot of work with AI vision systems. So vision systems working with machine learning and AI, that all closing that loop. And then we have the compute to controller, right? Which is really the heritage of OPC, but we're doing that in a much more progressive way. So, the punchline I wanted to leave you with is we couldn't be happier to more formally join OPC UA. The vendors that we're picking or our partners have to be literate, not only in what's been going on, but where this is going. And then we hope to influence through VDMA and SESME and others, a maturing of the OEM ecosystem, because we still, and so is the whole industry, are OEM driven in our delivery model. So I think that's the end of my pitch. And I know I only had a few minutes, so Stefan, I'm going to hand over to you. Okay?
Thank you.
Yeah.
Well, as mentioned, for us, it's a pleasure to have P&G here, doing a clearly statement, obviously. And it will be a pleasure for us that you also join the OPC Foundation. FLC will be the main topic today, but before we dive into this, because this is also critically important for the OPAF initiative, I give you some other short facts very quickly. The OPC Foundation, for those few who have not known or heard about this, is the international community to enable standardized, secure, independent data exchange, horizontal and vertical. We are growing. We are nearly going to the 900 level. And this is what I summarize. Everything is open. Specifications are open. You don't have to be a member of the OPC Foundation. Sample code is available free of charge on GitHub. And also, if you have a RAM start with buying a toolkit and building your product, enabling it with OPC technology, you can go to an OPC lab and increase the quality of your product without being a paying member of the foundation. We don't want to earn money with standardization. We want to bring the technology into the market because we believe on this. A very short hint that the board of directors had multiple changes. I'm not going through the complete list here, but everything where you see a star in front, it has been a new colleague. Sometimes it's a replacement because people go to early retirement, but also Mr. Fahd from VDMA has been democratically elected to the board of directors. The VDMA is the initiator of round about the half of the information models what we do for industry. So this is a significant message. And we have a new board chairperson. It's Holger Ken from Microsoft. Also, this is a interesting signal to the market that we have this. I'd like to welcome special friends here in the room. On that table, some colleagues from the company Equinor are there. They started their journey 2013, 2014 roundabout, and I'm happy that we have a public success story out on the web. One from the process industry, moving data, around about 1 million data point to Microsoft Azure Cloud, but also from the factory automation company Renault being connected via OPC to Google Cloud. And we will continue this, and you will listen to another great success story soon. I just super short address security. I'm not diving into all the details, but be aware that the OPC Foundation delivers a complete end-to-end secure technology. We are even supporting hackathons that hackers try to break in. The last 3 years, this have not been possible. There have been some reports outside where people made an analysis, but they forgot to switch on the security. Then it's not secure. We know this. This is like you run out your house and keep the door open. But overall, we have the process in place to handle it. We have 26 best security experts meeting every week and addressing all this all the time. Talking quickly about other topics, and I will not dive in all the details, but there has been a critical important infrastructure component called the GDS server. It's a global server providing services which are critically important. If you just have a one-to-one connection with something, that's always easy. Every student can do that in a couple of minutes. But if you really run a plant, a factory with multiple thousand devices, then the big question is, how do you do onboarding, certificate management, and this is what is available as commercial products. This is my main message. There is a spec since multiple years, but there is a commercial product available, and the message is also the world's largest automation company, Siemens, on their product marketplace, have this GDS server as a product available, and you can just download that from there. This is a critically important message also here to the OPAF community. I want to, before we dive into the details with Paul, and I realize you are active to jump on stage here. I also want to give you the message that OPCA is not just for the last mile to the physical asset, to the robot, to the PLC, to the RFID reader, whatever. It is also scaling completely to the cloud, and we are proud on this. And Status today is exactly describing our vision. We want to have one harmonized standard, which is for multiple markets, not only process and factory, also for energy and others, which is scaling really from field up to cloud and obviously back. And we are allowed to list all these logos from these companies because they have confirmed that they are supporting this OPCA to the cloud standard. If you say, hey, I have never heard about that in detail, again, I'm not diving into this in the detail here right now. But the OPCA for Cloud initiative overall has 3 topics. Number 1 is it's the world's largest repository of OPCA information models. It's up and running. It's free of charge. You can search, you can upload, you can download information models. This is to reduce your engineering time because you buy something, an asset, but in between you can download the information model, start with your engineering preparation, and once the device is there, you connect it and it's working. Second, Cloud Federation. This is how cloud systems between each other exchange information, because in a factory and a plant, a lot of times the manufacturer does not allow to immediately connect your asset to multiple cloud systems, from the manufacturer to vendor 1, to vendor 2, to vendor 3. Instead, first of all, he wants to have all information in his own cloud. And then he allows to forward some information to component providers of machines. And so the big question is exactly, again, how do you exchange these information? And obviously, you need a standard for this. And this is where they have chosen, again, to use a mapping of OPCUA for this cloud-to-cloud federation data exchange. And then we talk about field-to-cloud, cloud-to-cloud, and cloud-to-field communication. And I do address this just extreme shortly. We love MQTT, and I noticed that Alan is here in the room. Maybe you can raise up your hand. So he designed MQTT, and we love it, right? We don't fight against it because we have integrated that in our spec. For all the people who believe OPCUA is a protocol, no, it's not. So we are moving standardized information over other protocols which are relevant for the industry. But here you see that as an example that two PLCs transport the same content in a different way. It's the same variable, same values, but in a different way, and this is bad for the industry. And there is, and having this different mappings is not good. And obviously, the OPC Foundation defined a mapping. It has been an IEC spec back in February 2018. And this is exactly what all the big cloud vendors are supporting. MQTT is transport agnostic, so we need a mapping on top of that, and this is what we deliver. We would have transported over 3-meter demo walls with devices from a lot of companies, Beckhoff, Siemens, KUKA, Phoenix Contact, Mettler Toledo, and multiple more, and it will become the standard because everybody who is in the field level communication group and who is doing pub/sub over UDP will also do pub/sub over MQTT. So this will be the world standard, and I'm happy that all the big cloud vendors are supporting this either today or it's on the technical roadmap. And this means, and because it's critically important, you can move standardized information from the field up to the cloud completely. That was a quick rush through cloud activities and others, and I hand over now to Paul to make a deeper dive into the FLC activities, and then I will talk later on again. This is the clicker.
Okay. Thank you. Let's see if I can get the clicker working. I'm going to talk about FLC. Maybe a little background for me. I'm a consultant. I work for the foundation. I also work for Yokogawa some. I'm editor or chairman of the subgroup for the information model for FLC, so I know a fair amount about it. And hopefully I don't get too deep for this group, but feel free to ask questions too. What we have is a standard for controller-to-controller communication, and it also goes controller to device. That's what the standard is working on. It's been a long time in motion. The FLC group also standardizes and works with TSN and a few other pieces that we'll touch on as we go through this. The big thing is that this standard is had a couple release candidates already. We've just posted our 3rd release candidate for it. It's actually, we think it'll get published this time, finally, because we have prototypes running, we have demo walls running, we have testing established for it already, at least in a large part. So we think it'll be good. It's under a corporate review cycle right now, so all the members have access to the specifications. There's 4 parts to it, 5 parts to it. The slide looks like when it got copied over, dropped things off a little bit. But there's an information model, there's offline engineering portion, and there's also just a general overview and a network piece. And then there's the profile section that describes how we would test it. I'm going to run through the information model pieces a little bit on it and give you a general thing. We have an overall model for the system that shows you the health of your device, shows you capabilities of it, and it has a descriptor, which we'll touch base a little bit more on how you use the descriptors later, but it describes your device. We have an asset model that it's capable of. This asset model will let us model pretty much any asset that you may have. So you can look at the device and describe the device. It includes nested devices and complex devices. And some of the big things about the asset model is if you have an existing asset model, we can use those existing models. You don't have to define one using the FX information model. It's based on interfaces that are part of the sort of base UA/DI models. It also lets us support verification. This is important. When you go deploy something, an application that I wrote offline, I want to check to make sure it's being loaded in the right device, that this is the device it was built for, right? So I can confirm that what's available is the right information. We also have a function, We have a functional entity model. This model describes the functionality that's in the device, right? So it's a controller, it has function blocks, it has capabilities to do something, right? It has the inputs, the outputs, the configuration data. And it also has the capability to do locking. So when I'm setting up communications and I'm using this controller, I may want to lock the configuration that's in it so you can't change it anymore. Why? Well, if I'm controlling a machine, I don't want someone to go tweak a control parameter and have a problem. Or if it's in a process world, I'm making a grade of gasoline. While I'm making the grade of gasoline, I don't want anybody but my operator to be able to change set points and settings. So it has the capability of actually setting up locking. It has verification again. I can check to make sure all the blocks and all the configuration matches what I engineered offline. So when I downloaded configurations and I want to communicate between controllers from different vendors, I want to make sure that all of them are the right controllers and have the right configuration in them. I also have identification and capabilities of the controller described. This is useful when you're doing the offline engineering. So let's talk a little bit about the communications. So the key thing here is this is, in this release, set up for pub-sub communication. I don't know if you guys know the difference between client-server and pub-sub. In client-server, a client asks for data. I'm not sure why it's jumping. Client-server asks for data and the server responds. In pub-sub, the server's producing data, it publishes it. Client-server just listens, or the client side, the subscriber side listens for the data. So when you're setting up pub-sub communication, you have to tell the publisher what to publish. So part of the FLC piece is that we can dynamically create those publishes, set them up so that the server's publishing the data and the clients can listen. Multiple clients can listen to the same data, so it's agnostic as to who's listening to it. We've set up an information model that lets us have the communication piece separate from the data model that you have so that you can map it however you want to publish the data and send it out. And it creates logical connections between controllers. What I'm capable of doing is having bidirectional communication too. So I can see if someone's listening to it and if they're giving me feedback. So if I have a PID algorithm that's doing control, I want a feedback loop. We can set that up in FLC too. So it gives you an automatic feedback loop for it. And I have no idea why the slides are changing. Anyhow, I can also have just a heartbeat. If I want to know someone's listening to it, I can just check to see them getting data back. I have the capability to have unidirectional communication too. So if I don't need the feedback, I can do it that way. And I can even, for a temperature sensor, just be publishing data. And I don't care if anybody's listening to it. I just want to put it out on the network. And if someone wants it, they listen. I don't care. And you can also have the same side for subscriber. You can just listen for all the sensors and pick up the data of anybody that's publishing. So that's the key piece for pub-sub. So let's talk a little bit about offline engineering. So I mentioned a descriptor. And I'll figure out why the slides are on a self-switch mode. In engineering, if you want to build your system offline, you want to be able to configure it based on what the capabilities of the devices are. So we have descriptor files that are part of the FLC spec that you can download, save, use in your engineering tools, configure your system using the descriptors that were provided. The descriptors include the description of the assets, of the functionality that's there. And then it's very easy to generate a configuration. Descriptors can be updated by the engineering tools too if I add new functionality into it. And it's exchanged with other vendors. So it's a standardized way to exchange this configuration. So if I have 3 different vendors building different parts of my system, I can exchange the information and share it between the systems and engineer something. We make use of other standards so that when you go deploy these things, you can find the addresses. So part of what we talked about earlier was the GDS functionality. There's an alias name capability built into there so that I can go look up where a tag is. I've given this name FIC 101. That's where I'm supposed to read stuff from. At runtime, I can go find what controller actually holds that value so that I can dynamically set up my configuration beforehand and have it actually start up and run without having to do a lot of re-engineering. If I move the configuration to a different controller, it'll find it, right? So one of the other things that FLC also works on that I should talk a little bit about is safety, right? So there's a black channel concept for transmitting safety data over a process control system. So it means that I don't have to have the communication certified, I just have to have the protocol for safety certified. So this lets me actually transmit safety data over FLC or over OPC UA in general. What FLC has done is map this into the standard communications packages that we have, and it is just data. So as far as FLC is concerned, we're just transmitting data across the wire. Yet it's safety data. And it lets us run safety systems across FLC also. So what Stefan had mentioned is we have a wall that we were hoping would be here, but if we'd had it in February, you'd have seen this wall. It shows all the vendors' products, and they're all running. They're actually communicating FLC. This is not new, it's existing, right? I think the wall is elsewhere right now, but I have a video that will show you. Matter of fact, I think I have a QR code in here for it, and you can look at it. It has a lot of vendors. All these are different vendors that partake in our demo, right? So they have all the communications, all the FLC stuff is up and running. So let's show you the QR code. It's also up on the slide deck running at our booth. But this gives you a 10-minute live video or a video of the demonstration running. So someone narrated a view of it. It's a little long. I didn't want to play it because I don't have 10 minutes here, but it's a nice walkthrough of the demo. It describes the equipment, and feel free. It's a YouTube video. Okay. So if you're interested in more about FLC, I ran through this very quickly. We're going to have a much longer set of webinars on FLC coming up in July. Feel free to join us. We'll explain it in more detail and cover topics in a more thorough manner instead of our quick explanation. Hopefully this wasn't too quick for you. Let me talk a little bit about APL too. All right. I don't know if you guys are familiar with what APL is. It's Advanced Physical Layer. It's an IEEE standard that gives us 2-wire. Most networks are 4-wire. This is a 2-wire network. So all your old HART devices have 2 wires running out to them, transmit data. IEEE came up with a standard for sending network information across 2 wires instead. APL is adopted by Profinet, Ethernet IP, OPC, I think Fieldcom Group. There may be somebody else. I'm bad at remembering all the names, and I apologize if I miss somebody, but it's a way of standardizing the network traffic from these temperature sensors, pressure sensors that used to have 2-wire communication. Now you can get a network message. You can get far more information out of these devices. The key thing here is that with OPC UA at these devices, it lets us have a wealth of additional information directly from the device. You don't have to replace the the wiring to it either. And it lets us basically get the data from the sensor all the way up to the cloud, right? It's all OPC UA all the way through. Stefan may have more comments on this always, but he's up next, I think. So he's going to come back and talk to you a little bit more about some other collaborations and organizations we have. And afterwards, I think we'll be around to answer some questions. Thank you.
Perfect. Yeah, we don't have time to dive into Ethernet APL, but it has been established as an organization by P&O, ODVA, and Fieldcom Group. OPC Foundation joined late, but we are obviously also supporting this. And yes, you will find products with Profinet over Ethernet APL, same as Ethernet over APL. But for long run, I truly believe on OPCA over Ethernet APL as the one and only solution, because it's the one and only solution scaling to the cloud with all the information models. Good. Short update on collaborations. Again, just a few minutes to give you the idea that OPCA is not a protocol. It is how to move, how to agree in a kind of a world community on the semantic, how to define standards on information. And this is what is the second pillar of what we believe being the neutral organization on this. We don't believe that we as the OPC Foundation can solve all the challenges in the world, definitely not. And as we believe others can't also. And that's why we believe we have to cooperate extremely well with others. That's really what I breathe, what I believe on. And that's why we are overall having more than 66 plus information models. And obviously we do certification. But again, for low price, it is not what we want to earn money on. And we are also doing the certification on these information models, right? That you really know, okay, my pump, my robot, whatever market you are, is supporting the correct semantic as defined in the companion spec. Just to announce, we started just 2 new groups. One is about the global positioning. It has been initiated by an organization called Omlox. Omlox is hosted by the P&O, but they want to write a global positioning standard based on OPCA. And here you see how we cooperate behind the curtain for the best of the industry, right? And everything is under the same IPR policy. It's open for everybody. You don't have to be a member somewhere. You just download it and that's it. And this is exactly, you need the position of something everywhere. It doesn't matter if you're in process industry or factory automation. And this is what this group is starting and working on. And then second, I like to show you 3 slides on our key partner VDMA, where everybody in the world believes, oh, they are just doing factory automation. That's not true. Mr. Fahd, the leader, by the way, is here on this show also. They also defined already motors and pumps and other stuff. So these information models are there. They have been adopted by the industry already. But the key point and the key value of the VDMA is they do harmonization across different domains. And this is what they call UA for machinery. And the OPC Foundation and the VDMA is extremely closely connected, because the leaders of the 2 harmonization groups, we figured out it would be better that this is one person only, so that his left brain and the right brain is in the same brain, and we don't lose information with connectivity, communication between people. The VDMA is everything which sounds like this can be reusable. This makes sense that other working groups are aware of, is moved into this UA for machinery companion specification. That's a building block. And yeah, like Lego bricks, it has, for example, OEE data and so on. For batch starting jobs for machines and so on. And now this is a new message here. They are also working on energy management as a new building block. Because obviously a pump, a robot, whatever asset need a energy consumption API interface. And if every group, if every domain is doing that on their own, yeah, they can, because every group has the smartest people in the world, we know that. But then you have different standards on semantic for that energy management and consumption interfaces. And this is why, for me, it's critically important that the group is working together, and it will become, again, a puzzle piece, a building block in that UA4 machinery. It has been, again, initiated by the P&O, because Profinet, the field bus organization, they have a power management interface, obviously, which fits perfectly for field bus activities, but it doesn't really scale up into the IT world. This is where they proposed, let's use OPC for that. ODVA also mentioned, hey, we also have good knowledge because we have energy interface in ZIP, in Ethernet IP, so can we join? Obviously, yes, the group is always open. And together with the VDMA, we are working together to make it happen. The group has started already. This does not mean that you can't join. If you are a member of one of these organizations, you can join. You can actively contribute with, this is my use case I want to see covered, or you just in listen mode because you just want to monitor what is the group doing, right? With all of that, this was overall the workshop here. We started a little bit later and we are ending in time. So overall, we just made it in 40 minutes. We have some time for some questions, but overall, the most important messages, hopefully, of everything what you have heard about is, number one, OPCA is growing, the ecosystem is growing. We had a fantastic commitment here from Procter & Gamble. We will see later the year that the tobacco industry and other cloud vendors will make huge announcements. Number two, OPCA is also scaling to cloud. This is what you keep in your mind, and all big 6 cloud vendors have agreed on that and are actively supporting it. We will see massively adoption of that. And number three, the Field Level Communication Initiative has published their specification. It's out, public for everybody to download as a release candidate. We have a live demo prototype to validate, is the spec okay or not? Is it really working? It is up and running. You just have to fly to Detroit and see it live right now, or see the video, right? And they also the OPCA over safety demo is up and running. It is not academic, it is released. You can see it. And we also have a demo OPCA over 5G, because also 5G in some areas is a critical important part of the digitalization of the world. And we took care that 5G is exactly seamlessly integrated like TSN and other technologies. With this, I think you had enough time to think about a question. And Paul likes to run and walk. Yeah, oh, here's a question. Great. Yeah,
very nice update, by the way.
Thank
a lot
you.
of material you covered. So, Paul, I'm just curious. I know you and I have been in conversations working in OPAF together. What is the estimated time for the pub sub work that's underway, as far as it being available for vendors to come to the OPC lab to get tested? When do you think?
Later this year.
Later this year? So by the end of the year, probably?
Yeah, roughly. It's going to depend on what you're looking for. There's a number of profiles, right? So we test profiles. We won't have all of them, but we'll have some of them available.
So where could, I'm sure you'll have some announcements, but where can I get a list of the profiles, or at least the order or the priority of the profiles that you're looking at?
I can give you that.
Okay.
If you want.
And then the other thing is, I was looking up in the documents here for the sessions, and this presentation isn't in there yet. Is there a plan to make this deck available? Specifically, I'm interested in the dates that you had for the July timeframe.
The foundation's events are on its website.
Oh,
so
just
you
go to
can
the
go to the
website?
website
Okay.
and you can see those events to
Okay.
go log in.
The events are up on the OPC Foundation list anyway.
Okay.
But also on the profiles, Paul. I mean, sure you can support him. That's fine. But as long as I know, all the profiles from all the public specs are in a public repository anyway, right? Okay. And because you asked also for the material, I'm not sure if we get all the emails here of the attendees, but if we get, we can send it here as a slide deck here to everybody.
Any more questions? Sure. Way in the back. Anybody else have a question? You can hand the mic out beforehand.
And before Jeff is here, sir, one more question, because you asked when is PubSub available, right? Critical important to understand is that the PubSub is not bound and it's completely independent from other technologies. There's some misunderstanding on the market that OPC, PubSub, and FLC is only working together with TSN mandatory. That's not true. It is another option which you can, let's say, easily switch on. It will not be easily, but we try to make it easy. Switch on to guaranteed deterministic, but it runs also without TSN. Then UDP super fast, right? And so we don't have to wait until TSN is completely specified. Finally, we can set up the test tools, and this is exactly what Paul is doing before TSN is completely available, and test PubSub only on UDP. Huh?
So, side note for Ed's questions, I run the certification group for the foundation, so that's why the question was directed at when we could test it.
Yep, next question.
Thank you for the presentation. First of all, a couple of questions. One is technical about OPC UA FX. Which type of performance are we expecting without TSN in terms of real-time determinism? The second question is about collaborations. I see a natural complementarity with the high EC 61499 initiatives. So I was wondering what and if you are doing something on that regard. Thank you.
I can get the first question.
And I wonder about your answer. so it's good you answer first, I can jump on second.
Well, when you say deterministic, deterministic is, you have to understand what that is. It's not speed. It's that when I transmit a message, it will take exactly so long always to get there, right? So for much of what you're doing, you question what you need for determinism, right? Do you need it there in 1 millisecond, always exactly 1 millisecond? Then you're going to need TSN. If you have data that you need every quarter second and you can publish it far more often, then you're fine because you send the data every 50 milliseconds and you're guaranteed that you will have at least one piece of data every quarter second, right? So it depends on what you want for determinism as to what you're looking at. OPC-UA PubSub is in milliseconds. Very easy. We've shown that it transmits data in the single-digit millisecond ranges. With TSN, it's in the microsecond ranges that you can get data out. So it's very fast. The client-server communications is fairly reliable in the tens of millisecond rates. So it depends on the protocol you want to use and what you're doing. So.
Can you repeat the question?
Millisecond bounded jitter is what you asked for. Using TSN, yes. Not without TSN, because it's the noise
Paul,
on the
let me
network.
jump in. The official answer is, and that's true, the OPC Foundation till now had not made official measurement reports and countings, also not on jitter or whatever. Because we know, UDP is fast. It depends. It's the same cable, different cables, and so on. Do you split it?
It's on your network
we
load.
don't want to appear as a field bus fighting on other field buses, because then exactly you address on what is the speed and what is my jitter. What we want to appear on the market is, and this is a critical important message here from the demo, I think it's the first time in history that in factories you can order machines which have different ecosystems inside with different field bus system at the beginning, obviously, but you can combine them horizontally to talk fast in a way that it allows motion, it allows safety to exchange these kind of data. This has never happened. And this is exactly because you standardize interfaces, what Paul is dramatically helping here with inside the OPAF group and so on. This is the first key point. And obviously when you have done this part, then you can also go from the controller down into the sensor, because there's no difference, right? But right now it's too early. Some vendors made some measurements, but this has been vendor-specific measurements, and we want to do it in an organization-neutral way, and we have to deliver that. But allow us that we are just proud that the spec has been published last week, and we have a demo up and running. Okay. There was a second question about the 4099, right. I was in contact with a couple of people from ExxonMobil because, again, OPCA provides modeling capabilities and secure transport wherever horizontal, vertical, and we should work on a mapping, or maybe there is already a mapping 4099 into the UA namespace if the market is is crying for that and needs that, right?
I believe the Open Group is addressing 1499 more so than
This
UA.
is-
They're creating
Right.
an information model for it.
So we did it with other IEC standards like 31.3, right? The PLC open part, and yeah, if there is market demand, then there will be a group working on that also. Yeah. Are there other questions?
If you have more questions, feel free to find us in our booth. We're here the rest of the week, and
By the way, I was
Enjoy
reporting
talking
on
to
a
you.
couple of VDMA slides, and I just noticed that right in the door, if you turn back, Mr. Fahd from the VDMA is here. So he's on the conference. If you want to talk to him, just catch him.
Thank you very much.
Thank you so much.